So first, I'm going to start by talking about the repository built a BioC workshop. So I guess with a show of hands, how many people are familiar with this repository? Okay, that's about half the room. That's good. So this repository was first created by Sean Davis, who was running the Orchestra platform before the workshop platform that was based on Galaxy. And the main point of this repository is to provide a template. So it's a GitHub template repository where you can clone it and then use it as a basis to start wrapping your workshop material. So the main thing that it does is it wraps your material, which is generally written in R Markdown or Quarto Markdown, QMD or RMD, and it turns it into a deployable workshop. There's two elements to it. One is GitHub Pages. So sometimes when you go to a workshop, you can see a rendered HTML of the workshop that gets automatically generated from this repository. And the second thing that it generates is a container. So a little bit of background there. So Docker containers are a way to take software and ship it along with a small operating system. Generally, we use Ubuntu. So Bioconductor has the Bioconductor Docker containers, which are pre-installed with RStudio, R, and all system dependencies for Bioconductor packages. The idea behind the Bioconductor Docker containers, which can be found at github.com/bioconductor/bioconductor Docker _Docker, is to give a way to run Bioconductor and RStudio. So whether you just want an R session or whether you want a full RStudio instance and not have to worry about any setup. So whether you're running on Windows, on a Linux, or on a Mac machine, and whether you have everything installed in on your own machine, or you're coming with a new computer straight from the store, you can take this Docker container, run it on your computer, or run it on an online server, a virtual machine, and it will have everything pre-installed. So it will come with a small Ubuntu version. It will have on top of it R installed in it. It will have the free community edition of RStudio server. And then on top of that, it will have all system dependencies for any Bioconductor package and any CLAN package on which a Bioconductor package depends. So these containers are then used in the Build a BioC workshop template to build on top of that with your specific material for your specific workshop. There's instructions in the markdown of the repository, of the template repository. I'm not going to go through everything right now because you can read through this as you do it. And if you come to actually do it later, you can go through it in more detail. But I'm going to go through it so you can follow along and do your own workshop. I'm going to go through like the main points of things that you would generally need to change to add your material. So starting from this repository, you can click here to use this template, and you can create a new repository. Also, if you are following along and you fall behind, feel free to raise your hand to tell me to slow down. If I'm going too slow and you're bored, feel free to tell me to go faster. So here, when you create a repository from a template, what it will do is create a new repository, but have the entire history of that and the files that are in the template repository in the new repository that you created. So we're going to do that. I'm going to call this workshop demo EuroBioC 2025. A cool workshop about making workshops. Visibility public. And it is important to have the repository be public unless you are running on your own instance unless you want it to only be yours. Generally, any platform on which you want to run these workshops require them to be able to be pulled from the public internet. So you do have to have it public. and then create a repository. And that's the new repository that has the initial commit, which is just copying over the template repository. So if you look at the first commit, it will have as if you took every file from that template repository, copied it over to a new repository, and then pushed it to GitHub for the first time. So now, and I got permission from Tomas to reuse his material so that I don't have to put in dummy material. But the main files in this repository that you need to worry about are one, the description file. So like any other package, a description file will have the name of the package. It will have a title for it, a version. Thank you. And then the name of the author. And then the most important part for the creation of the workshop container is to have these dependencies. So when the actual workshop container is created, in order to have all package dependencies in the container, it reads this file, the description file. So if you miss dependencies here, then your users might have to install them when going through the workshop. Sometimes that's desired if you're trying to show them how to install a package, for example. If you're doing an intro to R, you might not want things pre-installed. But in general, people prefer things to be pre-installed to save time because it can take anywhere from a few minutes to hours if you're compiling from scratch to install things. And in generally time-limited workshops, you don't want your users to just sit there waiting for installations. So that's why it's best to have all dependencies here unless you specifically want to demo how to install. So I'm gonna start by changing this description file, and I'm gonna do everything in the GitHub UI. Obviously, you can clone the repository, do things on the command line or in your text editor, and then push it to GitHub. I'm just doing everything in the browser to kind of be the simplest possible. I'm gonna call this EuroBioC 2025 workshop demo. Building a workshop. And if you're following along, you can put real material. If you have an R Markdown or a photo Markdown that you have thought about wanting to turn into a workshop, you could use that, or you could use dummy material. Version, I'm going to start with 0.99. Just generally, generally, I don't know if it's convention or just something that we do, but what I learned from, I think, Marcel is to put the 0.9.9 until the first version, and then when it's ready for release, you just put 1.0.0. So that's just kind of arbitrary. And then my email. I'm not going to look up my work ID, so I'm just going to remove that. So for this, I'm gonna go to so we're gonna talk about this repository a little bit later, but I'm just taking material from here to reuse. Oh, what was the correct one? So this is Tomas's workshop that was built on top of EuroBioC workshop, the one that's being presented in the other room. And we're just gonna copy over the material from here. for the dependencies. And now, as you can see here, there's the dependencies that are just Bioconductor and all packages from CLAN, which you can just list directly. If you have custom dependencies, like for example, if you want to take a GitHub package that is not actually published on CLAN or Bioconductor, this is not allowed if you are writing a Bioconductor package and submitting it. But for workshops, it is allowed. So you can use custom packages as well. And this is generally the syntax that you would use to get packages off of GitHub. Now here, the URL should be the one for this repository. So it would be that. Sorry? Oh, yes, sorry. Can do that. And then that's good. So for bug reports, if you have something like an internal Jira board or something at your institution, you could theoretically put that. Most people just put the issues within the GitHub repository that comes automatically with the GitHub repository. And then the Docker image gets created automatically by a GitHub action that I'm going to show a little later. But generally, the name of the Docker image is just the same as the repository. Yes. The bug reports? Yes. Yeah, so it's a way in a description file to put custom packages. So if you go to github.com.
It used to be DevTools, but now it's Runs. It used to be DevTools. Okay. And now it's Runs. I think the center that runs sort of, DevTools is still builds and checks on your laptop. Yeah, and then you can still do install in DevTools. But it's the better way to do it, is it?
I mean, I think in the description file, yeah.
Oh, does it work? Yeah.
But in this example, this is a GitHub repository that is an R package, and it is installing the R package directly from this GitHub repository, not from a CLAN or Bioconductor repository. And yeah, so the Docker image gets created automatically. GHCR.io. GHCR stands for GitHub Container Registry. It's just the GitHub version of Docker Hub. And it gets created automatically and it's free to host.
Just GitHub is just a Docker Hub, but on GitHub, is it?
Yeah, GHCR is just a Docker repository on GitHub. And then others that exist are like GCR, which is the Google's, and then there's Quay is another popular one. It's an open source one, Quay.io, to host Docker containers.
Is there a hierarchy among those? They all cross-reference each other, or like, is there a reason why you choose to put one and not another, or something like that?
I think aesthetically, the one difference with Docker Hub is that the docker.io prefix is implied. So if you don't put any prefix, it will just go to Docker Hub. So you could just say Bioconductor/Bioconductor Docker, and that just goes automatically to Docker Hub. So that's one aesthetic thing. In terms of like practical things, I think rate limiting is a big issue now. Docker Hub implemented rate limiting a few years ago. So it's not free to put for any image that has a decent amount of traffic, you have to go to the paid plan of Docker Hub to be able to host it there and have people pull it. GitHub Container Registry is completely free so far. It goes through the packages distribution. So it will show up in the repository. That's the biggest reason why I prefer GitHub Container Registry, because it's free and it's within the same GitHub repository. So it's just all within GitHub.
Is like there's different types of containers, like the Docker Singularity, whatever. I don't we have to use Podman in our server. is there any differences in different workflows?
I don't have a lot of experience with anything but Singularity, and it's a different type of registry as far as I know. So the one time that I hosted a Singularity image, it had to be set up completely different. I mean, it is still, if you're hosting your own registry, it's kind of the same in that you have to have a server hosting it. I don't actually know what there is definitely a public Singularity hub. I don't know much about it and if they have rate limiting. The biggest advantage using Singularity or Podman is that generally the containers are made to not have to run as root. So in secure environments, it's generally better. However, for the person creating the container, it's harder to create. They now have ways to convert a Docker container into a Singularity container, for example. Doesn't always work, but for me, that's always been the easiest way to create Singularity containers, just taking a Docker container and turning it into Singularity.
GitHub can host both.
I don't know if natively. I can try to look it up. But no, I've never tried to host it on GitHub. So this would be the description file. So all of these are just kind of referencing the same GitHub repository that we just created from the template. And that's kind of the values here. If you want to host things in other places, you can change those. But I'm going to move this and then go up, commit, and then populate description file and commit. So now the description file is updated. And then the second thing is actually adding the material. So generally material, when you use the Build a BioC Workshop template, goes into vignettes. There will generally be this workshop example vignette to start with. And again, I'm going to go to Tomas's workshop and copy a vignette from there. So let's take the EuroBioC 2025 one. Oh, go. I'll go to edit and paste. So this would be the actual markdown material. So if you're authoring something from scratch, this would be where you author, or you'd author it probably in RStudio and then copy it over here. But this is ultimately what people will go through when they're going through a material. So this is your actual workshop material. And then things like these will also need to be added, but I'm just going to remove it instead. Or I can show how it's added. Sure. Commit changes, adding markdown material. Commit changes. Oh, I can also rename the file, which I did not do. 25 demo. Changes the name of the file. And yes, any references have to be in the repository. So if I go back here, go to inst and bibliography, you can find this bibliography. So if you want to add references, this would be the way to do it. So you would go into here and then inst, not images, then add file, create new file, bibliography.bib, I think was the name, yep. And then paste. Changes. Bibliography. Create changes. And then next was adding the figures that were referenced in the markdown. And I believe these are in here. So there's data and figures. We're gonna these EuroBioC 2025 logo. I'm just gonna download this and then upload it here. Add file, old file. Choose. Not happy. Do it again. There we go. And I actually need to move that, I believe. Yep. Yeah. Edit. And then if we add figures slash, it moves it. Move. So that's kind of showing how you can add references that are referenced within the. So if we go here, if you go to vignettes, now when it has the source image here, it will be able to find it because it was added under the vignettes. So that's kind of the basics of how to add the material when you have a markdown. Now talking about the automation that happens once you add them. So if you go to actions, and sometimes if this is the first time that you use GitHub Actions, you will have to enable them. So GitHub by default will have a window here that says actions are disabled. Make sure you know what the actions do, and then you have to click allow, and that enables them. Because I've used GitHub Actions before, they're already authorized on my account. I'm gonna stop the older ones because we only really care about the latest one. It will rebuild it every time that you push a commit. So you don't have to do anything when you make a change other than push and wait. But I'm gonna cancel all the old ones so that it doesn't waste compute. Since we only care about the built product of the last one. And then while we're waiting for this, I'm going to show on the already done one what the result will be. One element, like I said before, was GitHub Pages. So it will generally be added in your About section here as a link. And the format is always based on the name of your repository. So here, because the repository is owned by Microbiome and it's called OMA Tutorials, the GitHub pages will be at microbiome.github.io. So your username.github.io / the name of the repository. So if you go, you will see here the actual rendered markdown. So if we go to articles, EuroBioC 2025, this is the actual markdown that I was just showing in the raw format here. So if I go back here to vignettes, this EuroBioC 2025 demo.r markdown. You can see this training session introduces Bioconductor tools. And here is this training session Bioconductor tools. So this would be the rendered format that people can see in a more pleasant way with the pictures, not as just references, but actually rendered pictures with links and everything clickable. And generally, most workshop presenters will use this as the basis while they're going through. If we go a little lower, you can also see there's these blocks of code. So in your markdown, you can see here, you can add blocks of code. And then they will be rendered as these blocks that are easy to copy. So generally, especially if you want your audience to follow along when you're authoring your workshop, you should not embed code within the text directly, but create these blocks of code to make it easier to find them and to make it easier to copy the blocks instead of just copying it from text here. And so, I mean, we're talking about an R workshop, but in theory, if you do Proto Markdown instead of R Markdown, you can actually embed blocks of code of different languages. So you can have a mix of, for example, Python and R, and Proto will be able to render both. Those are generally better, for example, in Jupyter environments. Although RStudio technically does have a Python engine, but generally Jupyter is used when you use both multiple languages. But yeah, any questions so far about any of these parts?
Is there related other workshop that's in Jupyter? That's special.
For the authoring with EuroBioC Workshop, no, because EuroBioC Workshop is specifically for R. But for the second part of like contributing it to the workshop instance, yes, theoretically at that point, any container will work as long as the port is identified. And I can talk a little bit more about that later. Well, so that's the basics of EuroBioC Workshop. We talked about the GitHub pages, which is the rendered version of the Markdown file. Then the second important part is these packages here, which is the GitHub container registry that we talked about earlier. So if I go to OMA tutorials, you'll see this automatically created GitHub container registry, Docker container. And this is ultimately what is your workshop, containerized workshop. So this Docker image can be run locally on your computer, it can be run on a server, or it can be run through one of the workshop platforms, whether it be workshop.bioconductor.org, use galaxy.org, or Orchestra. Now, as an example, I'm gonna take this already done container, and I believe I have, just gonna close my personal things. Yep, I downloaded Docker Desktop earlier. So I'm gonna try to run it locally, just to show that. Oh yes. So when you do Docker run, if you are just looking to get an R console, you can just do Docker run, the name of the image, and then R, I believe. And that will pull the image and then open an R shell. So I'm going to show that first. And then I'm going to show the, I'm going to show the RStudio layer and how to do that. Just in the meantime, I'm going to prepare while that loads. Still have it. So this is a Galaxy wrapper. Since the workshop platform is Galaxy based, this is ultimately the configuration that allows workshop.bioconductor.org to know about your container. And this is what I wanted to show here. So ultimately, the repository becomes obsolete once you have the Docker container. Generally, it is good to use the EuroBioC Workshop template because it gives you the GitHub pages as well. And it has a command check so that it makes sure that your tutorial can actually run and that your vignette is properly done and it can properly build. But ultimately, if you, for example, are comfortable with Docker and you want to write your custom Docker file, you can make your own Docker image based on any RStudio image. And as long as your container exists and you know what port RStudio is gonna show up on, you can run any container. So we're gonna talk specifically about containers built by EuroBioC Workshop. That's the easiest way to do it, but theoretically, once you get to the container level, that's what matters. That's ultimately what we're running. And that can be custom built. It doesn't have to be built by this automation. But yeah, that's still pulling. I mean, I can talk about it while it pulls. Oh, I will do that. So if you want to run RStudio, that's when you need to expose a port. So RStudio runs at port 8787. So when I do with Docker run the -p 8787 to 8787, what I'm telling Docker is to take the exposed port 8787 from within the container and expose it on my local machine at localhost at the same 8787. It doesn't have to be the same. You can tell it expose 8787 at 80. 80 is the default HTTP port. So when you write like google.com, if you're going HTTP, it will default to port 80. HTTPS, which is the more common thing, will default to 443, I think, if I remember correctly. So it doesn't have to be the same, but generally, just to make it easier, to not forget, we use the same. But this would be the way to expose RStudio, as opposed to where's my mouse? The command up here, where I just ran R. So this will just go into an R shell and will not expose any port. This command would be if you want to just take the container image and have an R shell locally in your terminal. And this would be if you actually want to run RStudio from that image. We have to wait for it to download. It's a little slow. It's chugging along. Any questions while we wait?
Once and for all, in the GitHub actions, for instance, I'm getting an error.
Well, do you mind if I come and see what the actual error is? Yes. If I can show that. So while that's waiting, I'm gonna talk about the GitHub action a little bit more detail. So if we go to repository, so this secrets.github token is automatically populated by GitHub in every repository. It's not a secret that you have to add. However, you do have to change what permissions it gives it by default. So if you go in your repository to settings, and then here on the actions, I believe in general, this is where you change the permissions. And you do need to have read and write permissions if you want it to be able to also add the GitHub container registry. So this would be where you change it to read and write. And that will change the default that is granted to the GitHub token. Yeah. And thank you for that reminder, because yeah, that needs to be changed. And for action permissions, this will also be, so by default, you'll have disable actions, and you have to allow it here if you, but going back to the terminal, is it still pulling? Oh, no, it's not pulling. Okay. So version. So here you see the other session. If you want to connect to it interactively, then you have to add -IT, and then I haven't set the key bindings properly to go. Yeah. And then you'll have an active other session within the container, and you can do session info. Was it lowercase or uppercase? I can't remember. Yep. So here you're just in an other shell within the container that has your material. Can also, for example, just do bash if you want to be within the container, but just on the command line. So you can see it goes as root by default. And if you can see here, it's all the material from that repository. So if you go to vignettes, you will see the same thing as in the GitHub repository. So that's kind of the idea of what you get from the containerized version of the workshop. Everything that is in the GitHub repository ends up being in this container. All your dependencies from the description file are pre-installed. And you have this container that can run both locally and on any of the online platforms. So going back to showing the studio, I hope I don't need to do any other permissions. If you don't put anything at the end here, it will automatically start the studio session because that's the default entry point that we added to the container. And it will give you a password right here. Alternatively, you can tell it to run with no password. You can find more information about the different settings that you can add to the Docker containers at the first repository that I showed, the Bioconductor_Docker. So if you look through the documentation here, it does need a little bit of updating, but it will tell you all the information that I just talked about the port at localhost, the password. You can add this environment variable to change the password. If you don't add anything, it will by default just create a random password and tell it to you like this, the automatically generated password in the command line prompt. And yeah, so since this is running, we can go to localhost 8787, and there's the RStudio server that we just started. I believe username is RStudio by default, and then that's the password that I just copied. And this is the RStudio session with the material from the GitHub repository. So if I go to this one, for example, here you can also do the visual mode. So you will see it. Visual mode, okay. More rendered, and you'll see the actual pictures here. So it's a little bit closer to the GitHub pages version that I showed earlier, but it is still runnable. So if we scroll down to where the actual code is, there's, for example, this little play button, and that would be how you can run through the material just by going through it without typing anything. And you'll see in the console down here, it just ran through the code that I pressed play on. But you can also say you forgot to add something, and while you're doing the workshop, you need to add, I don't know, install a new package that you missed, or add a line because you had a typo in the data structure or something. You can also just type directly here. So I could do, I don't know, install .packages, or BioC manager install is technically what we recommend. And then, I don't know, BioC version, which already exists, obviously, but so you can do that, and that will just run. So that's a little bit about the container and how to run it locally. Any questions at this stage? Yes.
So, multiple users can use the same station as Studio, or that's another user in the same machine can open, can access the RStudio at the same time?
So theoretically, yes. However, then you have to set up a studio to have multiple users. By default, when you just run it, it will create the studio user and it will give a password for that. Multiple people cannot run as the same user because they will take each other's session. So if I'm here like in the current session and somebody logs in as a studio user, it will pop up this session has expired or somebody has taken the session and the other person will have the other session and you won't anymore. However, theoretically, a studio server can be run multi-user. It just requires extra setup. And I think the free version still allows multi-user. But that might be a paid, like a Studio Pro feature now. At some point, it was possible. I haven't tried it in a bit. But I think it might still be possible. Any other questions?
So the file system that you see here, that's of course just what's in the Docker container, right?
Yes.
So let's say I'm now going through the material interactively, I find some mistakes. I would have to somehow have another editor open in parallel so I can fix it there, because what I do here will be lost when I shut down the container.
Yeah, that is true. So if you're doing things locally, what you could do to mount something from your local machine is use -v or -- volume. So I can show that as a quick example. I'm shutting this down. I shut things down by just doing Control-C, which is just in a terminal, the default to give the shutdown signal. And actually, if you do it multiple times, you can force it to shut down. But if you just do it once, it will just give a shutdown signal, and then it will go through whatever process that, I guess, that script has for the shutdown.
Once you're inside a container, you shouldn't have errors.
Yeah.
Package is installed, that's generated. If the package doesn't install, the begins don't generate, or the test doesn't pass, then you can't get a container.
Yeah.
So
I mean, I
the
think
cool thing about using containers, this container system, actually, is just that you can end up with container type.
well, you can have typos in the
You can
text,
have
though.
typos,
Yes.
but we'll always have.
Yeah. But yeah, if you wanted to run the same container, but have, I'm gonna, for example, create the directory or demo EuroBioC 2025, and then I'm gonna create my file into demo EuroBioC my file.txt. And then what you can do is when you do the docker run command, you can tell it to mount. If I'm remembering this all correctly, from your local repository, from that directory, you can mount it into, for example, home, a studio, demo, or like shared files. And then if I run that again, and then I take this new password because I didn't set one, and then here I refresh, I will studio password. And then you'll see here the shared files directory, and that has the text that I just created. And if I then edit it and save it, and then I go back on my local file system here, and I look into demo EuroBioC, that file, I cat it, you'll see it changed. So when you mount the volume, you can take a directory or a file on your local file system and put it inside the container. And then when you change it in the container, it will automatically persist and change on your machine as well. This is especially useful if you're doing multiple RStudio sessions and you want to keep your library. So again, if you go to the Zoom moving, if you go to Bioconductor Docker, there will be a little bit about that here, I believe. Yeah, so we'll show you, for example, how you can mount from your local machine the library for your R packages. So this will mean that when you install packages within the RStudio session, and then you close it, and then next time you come back to it, your R packages will still be installed, because they're installed not just temporarily in the Docker container, but they're persisting on your actual file system. So that will allow you to reuse them and not have to reinstall packages every time. So ultimately, packages are just data. They're just files. So you can do this with files, like I showed, like the text file, but you can also do it with the actual packages. And that's one of the most useful uses of the mounting. I'm just gonna quickly plug in my computer before it gets too low. But any other questions about the Docker container or build a BioC workshop repository? And on the topic of the GitHub Actions, I can show that a little bit more. So if you go here, the basic checks. So these actions will first run a command check and actually make sure that your material works. It will build the vignettes and run through the code. So if you have errors, it will error out and not continue. If it all passes because all your code is correct, then it gets to the stage of building the GitHub pages and building the Docker image. So that's kind of a way to make sure that you don't accidentally push something that breaks your image and it propagates. So if you push something that breaks your image, theoretically, the last working version will remain as the Dockerized one, and the new changes will just have a little X saying that something failed, and then you can go through the GitHub action and then fix it. That's kind of a little protective layer to not accidentally destroy your own material, and make sure that it runs before you publish it. And this is all. So once you start from the template, that's kind of a base of like the default that is useful, but you can edit this. It's ultimately your repository. So if you're familiar with GitHub Actions and, for example, you want to host on your own container registry, you can do that. You're not bound to what is already in the action. That's just the starting point. But if there are no more questions, I'm gonna move to talk a little bit about the workshop at bioconductor.org. So that's saved in this file. Here we go. Yes.
Once you file, like so, is there any version control that you can use to push the modification from the GitHub directory, or because probably I'm not familiar with it.
I mean, theoretically, yes, you can have Git installed in the container, and then you can clone the repository and then push, but by default, no. So by default in the container, things are just copied over to home-RStudio, not as a GitHub repository. So you can't just edit here and then do git push. You'd have to actually add git and then clone the repo or add the remote. Theoretically, it is possible because like the container does have internet access, So you can copy the file and push it. But by default, the way it's made is not to be linked to the GitHub repository. It's just copying over the content and making a container that has that directly in Home Studio. Does that make sense? So yeah, so the second part of this workshop presentation is the workshop.bioconductor.org. So this is a Galaxy-based workshop instance. It is running just Galaxy. So it's a version of Galaxy that's slightly modified to remove. So if you go to use galaxy.eu, so it's for that EuroBioC, you will see there's a few more options here. To make it simpler and not confusing, a lot of the options that we don't use for the workshop were removed. A little bit of aesthetic changes, like this says workshops instead of setting tools. And then the sections are what we have as the various events. But ultimately, the base software here is the Galaxy open source software. And what I wanted to show is how we get from that container and that build a BioC workshop result to adding it here. So what, yeah. Oh yes, sorry. So there's this Shiny app, which was created by Marcel on the Bioconductor Core Team. And this is the easiest way interactively to add. Oh, that's sad. Just needed to refresh a little. So this is the easiest way to add your repository without having to do anything manually. So if we take the microbiome OMA tutorials as an example, I can just tell it here that I want microbiome/OMA. Oh. Sorry? Oh, so was here the first app on workshop.bioconductor.org is BioC Workshop Submit. And then you click Run Tool. And then you'll have it in your interactive tools. So this is a Shiny app. So another thing that I created at workshop.bioconductor.org is an automatic way to wrap any Shiny app. So this is a little bit tangential, but if you go to bioconductor.org/BioC Shiny, maybe not BioC Shiny. What was it called? Oh, is it on? It might be on my repository. Maybe I never pushed it. Oh. Well, I'll find it later. This was not part of this anyway, but there is an automatic wrapper for the Shiny apps as well. I guess for the workshop submit one, it would be, I believe this was the repository. Oh. BioC workshop submit, is that typo? So this Docker file it's still a work in progress. Like for example, here is just using a gist that I created for the index.html default. It's a tiny thing, just the default thing for the Shiny app to be able to run easily. But theoretically, if you just take this Docker file and then it's somewhere in a template repository, I just can't remember the name. And then the scripts and workflows here, along with the Galaxy wrapper template, it will actually create. So all you have to do for containerizing your Shiny app is add the app.r file and then any R code that you might need, but you don't necessarily have to if you are just using something from an external repository. And from this app.r file, which is the entry point for the Shiny app, it will just automatically create a Docker container. So same as BuilderBioC Workshop Submit does for just the regular R Markdown. This is the same version for the Shiny app. So you'll get the container. The container will already have everything needed in terms of the default HTML file to give you the automatic window at when you go to the port number.
Is that a way to have a lot of Shiny apps that we could have like a very different kind of training thing there? I can imagine that might be useful for biologists.
Training through Shiny, like an IC training or something like that.
Yeah, for IC training, but also like for just other, even just a way of like giving a front-facing view for a lot of these Shiny apps. One of them with Shiny apps, the other.
Needs server.
Oh yeah, so this has an embedded server within the Docker container. So that's how it just runs as any Docker image like our studio. So you don't have to, it's running this is the same as running the our studio there. You just do Docker run image and the Shiny app is just available.
So you could potentially then have a thing where it's like try out these Shiny apps, you know, do it.
The take-home message is anything that you can get in a Docker container, which is basically anything, can run on this platform.
Yeah.
That's what it comes down to.
But I'm just thinking of like, you know, a Pinterest for Shiny.
Yeah, no, I mean the
Want to deploy it, test it, it does what you want, shut it down if it doesn't do what you need. Because sometimes with Shiny apps, you have to actually, download what it do it. It's just like there's a couple of steps there.
yeah, no, with this repository or the template repository on which this is based, you just have to define a Shiny app and app.r and whatever R code you need in the R file, but all the wrapping, containerizing, adding the proxy server, all of that is done automatically within the Docker file that's pre-populated there. So it does make it easier for someone who's not familiar with Docker to just write a Shiny app and have it deployable. Yeah, a few years ago, what I was trying to do is the concept of BioC deployable, to have the Quarto, the R Markdown, Shiny, just all of them just be under the deployable kind of umbrella. But that never really took off, so I kind of dropped it. But all the technology is still there and it all still works. So yeah, if you have any Shiny apps that you want to containerize, it's fairly easy to just plop it into the template repository and everything happens automatically. But yeah, so back to this Shiny app here for the workshop submission. So if I click populate, it will actually go to GitHub and take from the GitHub repository all the information. So it'll pre-populate it here, for example, the description, the GitHub repository URL, start file. It's not very good at detecting. So here, for example, if we want the start file to be probably EuroBioC 2025, you would just do vignettes / EuroBioC 2025 as the markdown starting. This usually populates on its own. I don't know why it didn't, but so this is the container image we're talking about, or my tutorials latest. Oh no, latest is here. And then if you don't, a second thing about the workshop.bioconductor.org is that it's made originally for BuilderBioC Workshop to have a pre-made container image. However, if you just have a markdown file and you don't want to deal with the repository and it's just one markdown file, you can actually have all of these be empty. And instead you just have the description, and then you can populate here the list of packages that you want to install, and then a link to a vignette. So if you have it on S3 bucket, on your, I don't know, server in your university, or just in a GitHub repository without any fancy things, you just put the URL here, and the automation will actually build the container in the back. So I'm not gonna focus too much on that. Since we started from BuilderBioC Workshop, I'm just gonna go on that recommended route, but if that seems like overkill for your small use case, there is a slightly easier way to just give it a markdown file instead. And then here, workshop ID is arbitrary. It has to be all lowercase, generally to help with statistics, because there's some automatic statistics automation that I'm going to show at the end. We put as a prefix the name of the event, because then I can say event stats EuroBioC 2025, and we'll automatically pull from the database all the statistics of how many launches were for each workshop and all of that, and it detects them with this prefix. So here I can do demo workshop, and then section is what will show up here. So if I go to workshops, you see this section name up here, that it corresponds to the section name here. I'm actually here, 2025. Yeah, everything else is just the default stuff. You can see when you click render, this is what comes out. And this is ultimately, and you can click create issue, and it will automatically have a bot create the issue for you. So this is kind of a little shiny app that automates the process of generating this, so you don't have to do it manually. But the actual automation magic happens in the workshop contributions repository. So here, if I go to issues, you can see this one was created by BioC Workshop Dev. That's the bot from the shiny app that I just showed. And you can see here the request that was just generated from here. It was pasted into here. So to show this happening in real life, so this is ultimately how all the workshops the other workshops that are happening today, how they were deployed by this automated thing that I created. So this is the tutorial that we're using as an example, Tomas's tutorial. And this is ultimately the command that activates the bot. So here, as a little bit of context, so the thing that gets generated automatically says /request. /request can be done by anyone. So you as a user can send this request with /request. All it will do is make sure that there are no issues with this format. So we'll make sure that the ID is the proper format, that there's no like characters that shouldn't be there, just a linting check essentially. You do need an admin to come and do the /test, which will actually deploy it. A little bit of background, /test actually just deploys it to production. Originally, when I was designing this, the idea was that there's going to be a test server and then a production server. So /test was going to automatically deploy to the test server for people to try it out. And then there's going to be /prod to deploy to the production server. I'm only one person, and I did not want to maintain 2 separate instances. So the test server just became the production server. And just for historical reasons, because I never changed it, it still says /test. But this will actually deploy to the production server. And we're going to do that now. So I'm going to show how when doing the request, it takes about 4 or 5 minutes, and it will actually automatically change the live production server. So we're going to do this request now, and then you're going to see how it automatically shows up on workshop.bioconductor.org. So going back here, I need to be signed in, and I believe signed in here. Workshop contributions, issues. Oh, cool. I see somebody submitted a new one. Cool. Yeah. So, yep, you filled out the section, the thing in the Shiny app, and the bot just automatically created the request here. So an admin, which is me right now, would have to come, copy it, make sure it's fine, and then say test, and that will automatically deploy it to the instance. I'm gonna, I mean, if we have time, we can try actually deploying yours as a live thing, but I'm gonna do it the one that I know works now first. So coming to issues, and then this one that was created by my request. Oh no, is this what oh yeah. Okay. But I'm gonna paste this. So here I'm gonna change this ID to workshop demo, and then demo propagation or workshop demo. So a little bit of what each field means. When you go to workshop.bioconductor.org, which I have open here, title corresponds to this bold text here, and then description corresponds to this not bold text right after it. So, second, I'm gonna fix that. Oop. Okay. So here you can see the way it was originally. You have orchestrating microbiome analysis with Bioconductor. That is the title. The description, introducing bioconductor tools for data science. That's the description. The section is the section that you want up here. If the section exists, it will add it to the section. If the section doesn't exist, it will create it. The start file is what you want to automatically open. So if I run this workshop right here, wait a little bit for it to open. Hopefully it still works. The capacity is not too used up. Okay. We're gonna just look at the back admin dashboard for a second. So this all runs, so a little background. The Galaxy instance is running on Kubernetes. That allows for scaling. It allows to not have to deal with putting reverse proxies. It is a little over, it's close to the limit. But so here you can actually see the full cluster information of what all the workshops that are happening are actually using. And as a small tangential thing, let's add a node together. So go to workshop.bioconductor.org. I put in my admin password, go to cluster status, nodes. A little bit of background here. So this is based on the Genomics Virtual Lab, GVL. It was a project originally based out of Melbourne Bioinformatics. It was a project that me, Nuwan Gunasekara, and Enes Afghan from the Galaxy team worked when I was on the Galaxy team before Bioconductor. And the same infrastructure stack, it's all open source. So I reuse the same infrastructure stack, which is called Cloudman, and the Genomics Virtual Lab, the GVL, to just use as a base for deploying a Kubernetes cluster. So that's why you'll see GVL up here, and all of this is Cloudman, which yeah. So we have, for example, statistics on memory usage. You can see over time. Yeah, there's a little bit of monitoring. If anybody's interested in that, like dev stuff, please ask. But I'm gonna just add a node so that there's more capacity for the other people in case people are waiting and not getting instances. I'm added to Excel and add. And that will, so the credential, this is all based on the OpenStack API, which is a open source API that you can put on top of a cloud. So all of this is running on the Jetstream 2 cloud in the US. It's an academic cloud from the National Science Foundation. And the allocation number is BIR 19004 right here. So it is currently National Science Foundation infrastructure that is backing this entire thing from the US. But there was an intention. I submitted a grant for it, but it was not funded. Yeah, the Oscars project.
Benefited a lot.
I'm-
Find another route. That Oscars program, I think, didn't fund very much stuff at all.
Yeah.
They'd given away most of the money first round. So I think it's a case of keeping an eye on what kind of she's basically just.
Yeah, I mean, like I've deployed it before on the Denby cloud in Germany. They have OpenStack on top of Denby. So that would be, for example, a very easy thing to do because you just put in the credentials and it just does it because it has OpenStack layer. But yes, theoretically, like all we need is a cloud and then some funding for some time to just do it. It wouldn't take too long. Like I think probably like 3 months is enough to get it up and running with all the automation and stuff. And then, a little bit of more time maybe for like support and like tweaks, but it's all the tech is there. It's all open source. So theoretically it is very possible. Just have not had the time or funding to do it. And there is a potential plan to create a mirror in Australia. So the Galaxy Australia team has offered to let us use, at least for a prototype, their Nectar cloud allocation. Nectar is same as Denby, same as Jetstream, just in Australia, an academic cloud. So just having that direct access just makes it easier. And potentially maybe for BioC Asia, we might try to deploy an Australian mirror for it. But yeah, yeah, so this launched. Cool. And yeah, so originally I was launching this to show the start file portion. So sorry for the parentheses, but backtracking. So this, you see how it automatically opened EuroBioC 2025 here. That is because in the request here, here, it says start file vignettes / EuroBioC 2025.rmd. That adds to the command in the wrapper a little bit of code to make RStudio just open that file for you. It's mostly useful if you have multiple markdowns and one is referencing the other and it's not clear where to start. This will just automatically open it for your user so they don't get confused. And then, yeah, this is the source repository. The source repository is mostly useful because there's a way to make it repull material. So if you made a tiny change, like for example, just a typo in the text without changing any dependencies, no packages, it will rebuild the image eventually. But when you have the source repository here, it can also be set to re-clone it at startup. So that's a way to get these small tweaks without having to wait for the container image to rebuild. But ultimately, this request is all that is needed. I'm going to just change the title to workshop demo.
A long time ago, building these, every small change we ended up that did a GitHub committee that actually build a container and it wasn't.
Yeah, it's turned off by default because they're all running on the same server and GitHub does a rate limit. So if you do like 100 Git clones within like 5 minutes, if all participants are like launching at the same time, it will eventually stop working for someone because it hit the GitHub rate limit. So by default, it does just take the stuff from the Docker container, but that is there to be able to add. There's another small portion to add that will make it pull it. It's not recommended for big workshops because it hits the GitHub rate limit. So description, adding a workshop to the production instance live. And then we are gonna believe that is all that is needed. So we're gonna click comment. And then this is then listened to by a bot. So if you go to actions here, you can see this /command dispatch. This action reads every single comment. And if it sees that the comment starts with a /command and that command is registered, and that comment was made by a GitHub account that has permissions, it will automatically run the second workflow. So if you make a comment now with /test, it will just stop here. It won't actually dispatch it because you don't have permissions. But because I have admin permissions, it listens to my command. So then this little 8-second GitHub action checks the request and then dispatches this actual workflow, which does everything that we want to push it to the live thing. So I'm gonna go, well, it takes about 5 to 7 minutes to run. I'm gonna go through each step and what it does. So this is just part of the dispatch to just recognize and dispatch the command. Here, the free root space, this is an action that I created a few years ago because by default, the free GitHub action runners, they have on them about 60 gigs, I believe. I did the right in the markdown there, the data. Yeah, so they give you about 70 gigs of root space. However, each runner comes pre-populated with a bunch of software like Python, .NET, Android SDK, a bunch of things that if you're just doing R, you don't necessarily need. So if you actually look at the beginning of the action, and this action just deletes all those things. So if you look at the beginning of this, it will, well, you have the option to remove all of these. So .NET, Android, Haskell, Google SDK, Firefox, AWS CLI, a bunch of things that just come pre-installed. And in this case, we just care about building the Docker image. So this action frees up all of that software so that you get close to 60, 70 gigs, which allows big Docker images that have data in them to build on the free GitHub action runners without having to set up your own runner or to pay GitHub for one of the paid ones. There's still the limit of around 50 to 70 gigs. But for most cases, that is enough. So this was kind of a little trick that I did to be able to build on GitHub Actions without build Docker images on GitHub Action without hitting the free volume limit. So you can see here before removing it, the size is 72 gigs, but only 27 gigs are available when it starts. And then when it does all the removing, it will print out everything that it is going through and removing, and then at the end it will print out another summary, the disk-free -h summary, to tell you how much it freed up. So I can, in the meantime, look at the last one that ran yesterday. Here. Oh no, this morning, yeah, because we updated one of the containers this morning. So it started with only 27 gigs available. And then by the time it was done removing and it does list everything that it's removing, there are 60 gigs available. So it freed up about 35 gigs, and that allows big Docker images to actually build on the free tier. So you don't have to pay GitHub and by extension, Microsoft. And it's still using the free runners. It's just freeing up all the software that you don't need for this purpose. So I'm gonna go through this while the other one is still going to just talk about all the different actions. So after it frees up the space, then it will just check out the repository. So it will just get the information of this workshop contributions. So these defaults for all inputs are based on that information that was in the /test command. And it will also tell it to you at the end, I believe. Okay, so yeah, there's the source URL. It's if you don't put so here the source URL was actually created to be the one from the GitHub repository of the workshop, which is this one. But if you don't have one, if you go through the method of just putting in an R Markdown link and the list of packages that I showed in the Shiny app, it will automatically create an issue. Well, it will link, instead of to your repository, to this issue of the request. So if people have problems, this ultimately ends up being what is shown. If I click on workshop, right here, this information here. This is an auto-generated bioconductor wrapper. See the source of this workshop or report issues at. This is the link to the repository. If you don't have a repository because you didn't start from Build a BioC workshop and you just started from the default just giving a link to a markdown, then it will just link to this GitHub issue instead, just as a way to have people be able to communicate with the workshop author somehow. Where was that here? So that's just taking the defaults from that. So here it's installing Helm. Helm is package manager for Kubernetes applications, essentially. Kubernetes is a way to orchestrate Docker containers. Excuse me. So, I mean, this is very dev stuff, but essentially, if you have multiple nodes and you want to run a bunch of Docker containers across multiple nodes, have them communicate with each other, Kubernetes is kind of the way to define all the containers that you want to run, how they should communicate with each other, what shared file systems each should have, what volumes each should have, just all of that. And then Helm is a software that packages all of that into an application. So Helm is used to install Galaxy in this case. The Galaxy Helm chart kubeconfig is what is used to point to the Kubernetes cluster. So ultimately, this is the cluster that I was showing earlier here, this cluster. Here's the download kubeconfig or copy kubeconfig. That is ultimately what is running here. It's because it's a secret, it's hidden. Then install kubecontrol. That's just a command line for the Kubernetes interface to talk to Kubernetes from the command line to the API. This is just an action that gets the current job URL just when it comments. What was it? Oh, I'm just going to reopen it. It's fine. So if I go to one of the done ones, you will see there are comments that are from my account, but are not me. So these auto-generated responses, this action log will take you directly to this URL. And this is the step that actually finds out what this is and then puts it in the comment. And then the deploy part is the most important part. So it runs a deploy script. The script is so all of it is open source. However, it is not well documented because it's just mostly an internal thing that I've been using. But here's the deploy script. So this is what actually creates all of the configuration files for Galaxy. It adds to the toolconf integrated tool panel for Galaxy. And then it does the Helm upgrade to the live instance. So if you want to see what it actually does without looking at code, we can look at these commits. You can see this commit from this morning. So it will push the name of the container image as a separate file, makes it easier to keep track. This is a file that has the configuration for the Galaxy. So it adds that ID to the two configuration files, toolconf.bioc.xml and integrated tool panel.xml, which, there we go, integrated tool panel.xml. So it adds the lines where they're needed within the section. So you can see this is the EuroBioC 2025 section that it got from where we set section in the command. It adds it here. This creates the actual wrapper. So each tool in Galaxy needs a wrapper to define what container it's running, what port to expose, and the name, which is what's showing up in the user interface. So everything from that command in the comment is being translated to this XML file for Galaxy. There's the container, there's the port 8787, like we showed in the local host, because ultimately it's just running the same container, the same way that we were running it as localhost earlier, but running it through Galaxy. These are some environment variables that get injected automatically that are not currently used here, but in the last portion of this, what time is it? Oh, that's still on American time. Thanks.
Principally in 5 minutes would be poster session.
Okay. Okay, so I'm gonna speed through this a little bit. But yeah, so this is the little trick that I said about opening the file automatically. But yeah, this is the XML file. It gets created, and then Helm upgrade pushes it to the live server. Has our command finished yet? It is at the deploy stage. So once actually, it is waiting. I can show in the background here. So the one nice thing about Kubernetes is that you can do what is called no downtime upgrades. The idea is that it's putting all the configuration file in these new pods. So they're coming up with Galaxy. You can see how it just terminated the old one. So it waits for the new one to pass all checks to make sure that the configuration is correct. If you push something to the production server that is wrong, it won't take the server down because it will not take down the old configuration until the new one passes. So that ensures that, for example, now I just changed the live server, but if I had put something wrong, the instance doesn't go down for the other workshops. So Kubernetes has that as a feature. Helm can be done to wait for those because they passed. You can see it's replaced them. So this is a new Galaxy server that just started up 2 minutes ago. It waited until everything was correct, and then it took down the old one, pointed it to the new one. And now if we go to workshop.bioconductor.org again, you will see that the new workshop has been added. So all of it is automatic, just giving that command in the comment, the entire pipeline for generating all the configuration files, applying them, making sure everything is correct. All of it is automated. The idea is that this could be a self-service at one point where people can just do it without having to worry about all of those details, sysadmin details in the back. But yeah, so this is now a runnable workshop. If I do run a tool, I can only have 2 running at a time. So I must stop these old ones. And then the one that I just ran will theoretically start up. Here we go. And now we wait a second and refresh. And this is the new workshop that we just added. So that's how everyone who did workshops, that's how the workshops came to be on this platform. That's how you can get your workshop on this platform. Yeah, one last portion that I will quickly show, which is what I hope we will have on the workshop.bioconductor.org platform if we keep it. So when working with NS primarily from the Galaxy team for the joint conference that we had in the US this year, because Galaxy and Bioconductor had a joint conference. One of the projects for the conference was to make a Bioconductor container that it works on the usegalaxy.star network. So usegalaxy.org, usegalaxy.eu, usegalaxy.org.au. These are free servers of Galaxy that run in the various continents. Am I logged in here? I believe I am. And the main thing that we worked on is be able to have inputs and outputs. So if I upload something to Galaxy, which I did here by pasting, well, I'm just going to use it from here. So I pasted here a text file that says awesome data. I uploaded it to Galaxy. Then when I look for tools, I can look for Bioconductor or RStudio. So this RStudio with Bioconductor. And here you can select from your text, from your data that you have in Galaxy. So I can start with this and then click Run Tool, which I already did, because there's a queue. These are public servers. When you run a job, it goes in a queue. When the queue frees up, your job runs. It's public infrastructure, so you have to wait your turn, but most of the time it runs pretty fast. But this is RStudio running within Galaxy. So here you have Galaxy inputs, and this is the awesome data.txt file that I had uploaded here. So it automatically brings it into your interactive tool. And then, so I believe these functions were created by Helena from the Galaxy Europe team. And here you can do Galaxy put. So if I create a new file quickly here, okay, there we go. New text file. And I write my new data, and obviously you probably want to run some R code and generate data, not just create a file that says cool data, but just to show. And you can save it in Galaxy outputs for the automatic thing, but you can really save it anywhere. So if I do my output file here, and I go back to home, now I have this file that is, say, was generated by the R script. It's my output file. Then I can do Galaxy put, and then my output file, and then enter. And that will automatically talk to the Galaxy API. When the Studio instance was run, it injected your API key for your user within the container. So that's how it is able to talk back to the Galaxy server. So it talked to the API, and now you can see here, my output file is now in the history item. So this is a way to be able to actually get data out of the RStudio interactive tool and give it back to Galaxy. The idea is to, so this was created, I mean, this is a container that now gets built automatically as part of Bioconductor Docker. Enes Afghan, who's on the CAB, on the Bioconductor Community Advisory Board, and is a developer on Galaxy, worked on creating the container, and then I worked on adding it to the build stack of Bioconductor so that it gets built automatically. So if you go here to extensions on the Bioconductor Docker and then Galaxy, you will see the actual Docker file and everything that is creating this container. The big difference is that because these use Galaxy.star servers are not running on Kubernetes, they are using Docker to run interactive tools instead of Kubernetes. They require a proxy. So there's some reverse proxy setup that the admin does. And that's why we needed a special container. It's still based on the same Bioconductor Docker container. However, it includes a proxy configuration within the container that Enes added so that it can run on the use Galaxy servers, not just the workshop.bioconductor.org, which runs on Kubernetes. Kubernetes just gives you a ingress proxy directly. So you don't have to actually do any proxy setup, it's just automatic. But yeah, that's like a new feature that is now on the usegalaxy.eu and usegalaxy.org servers. The Docker image is built automatically as part of the Bioconductor Docker process. So now we have, if we go to hub.docker.com, at Bioconductor, there's an RStudio Galaxy, I believe is what it's called. There we go. So this will build automatically as part of Bioconductor. There's 320 here. And then actually, yeah, because I moved it to the GitHub container registry instead. So if we go to where I just had it open, I'm just gonna here, you'll actually see on the packages and on the Galaxy RStudio, you'll see the new version here. So this gets automatically built as part of the build process. So whenever the container for devel or the container for release 321 on the bioconductor side gets updated. For example, when R 4.5.1 came out, instead of R 4.4.0, we updated it on the bioconductor side, and then it automatically rebuilds the Galaxy container as well. So that there's always an up-to-date Galaxy compatible container of RStudio built by Bioconductor with the Bioconductor system dependencies. This will hopefully be a feature on workshop.bioconductor.org soon as well. So you'll be able to actually persist data, and it won't be just for ephemeral instances that disappear with all the data. Once you're done with the workshop, you'll actually be able to use workshop.bioconductor.org more like Galaxy to actually have some data there and come back to it and be able to have data in your history. But that's kind of all I wanted to talk about. Thank you for listening to me ramble for an hour and a half, I hope.
Thank you, Alex.
Yeah, any questions or things to talk about?
Maybe.
Okay.
I was wondering about the platform that he chose, was because it's free. It's free available for academics or also for.
So it's running on the National Science Foundation Jetstream 2 cloud. It is a bioconductor allocation. We don't pay for it. We apply for credits. It is free to use for anyone in theory. However, the infrastructure needs to be scaled for any big events. So if you want to do, for example, like a small class of like 5 people, that you can probably do anytime year round. The instance workshop.bioconductor.org is there. But if you want to do like, say, 15 people and make sure that you don't have issues, then you have to submit a request. So there is an email, workshop@bioconductor.org.